So let's move on to conjugated diene chemistry and look at one of the big organic mechanisms for the chapter, 1,4 electrophilic addition. So we've seen electrophilic addition in the past with the alkene chemistry. We had 1,2 addition across a double bond where we added hydrogen on the less substituted side of the bond. That's the side which had more hydrogen, and so the reaction followed Markovnikov's rule. And the bromine added on the other side of the double bond, the more substituted side, because our intermediate step would have a more substituted carbocation intermediate. If we introduce a conjugated system with multiple double bonds separated by single bonds, we can still see that 1,2 electrophilic addition, but we can see it across one double bond or across the other double bond if we use a limited supply of the hydrogen bromide. However, there's often with the conjugated dienes a much more commonly seen reaction where we actually involve the two pi bonds over the course of the mechanism. And we produce a product which is still has the addition of the hydrogen and the bromine, but that addition is separated not by the two carbons in the one double bond, but across the four carbons in the two double bond. So we call it a 1,4 addition of the hydrogen bromide. So let's take a look and see how this mechanism can occur. So let's look at an example here with a conjugated diene. If we look at that final product, carbon 1 is where the hydrogen adds, and then 1, 2, 3, 4. Carbon 4 is where the bromine adds. So let's take a look and see how this mechanism takes place. Starting with the original conjugated diene and the hydrogen bromide, it's just like the 1,2 addition where that pi bond reaches out like a nucleophile and grabs the hydrogen, which is having the electrons pulled away from it by the more electronegative bromine. So we know the bond is polarized, and as that carbon to hydrogen bond forms, it means that the hydrogen to bromine bond has to pop, has to break, so that we don't have too many electrons around the hydrogen. Remember, it can only have a duet. So we start off with a carbocation, as we've seen before, with the 1,2 addition. But remember that carbocation carbon is sp2 hybridized, which means it has an atomic orbital above and below the plane, just like the carbons next to it in that carbon to carbon double bond. So those pi electrons in the double bond are not localized between the two carbons, they are delocalized around all three carbons, and that gives us the possibility for resonance. So let's look at the next step with that electron-hungry carbon down here from the opening of the double bond. We've got pi electrons next door, so we can show a resonance structure as those electrons move across and pops the positive charge up to that carbon 4 in the chain. Now we can see why it's a 1,4 addition. And that bromine, like a nucleophile with its negative charge and lone pairs of electrons available, uses a lone pair to make a new bond to the carbon, and we produce our final product. A 1,4 electrophilic addition across the two double bonds. Notice in our final product, we still have a pi bond, which is now positioned between the original two pi bonds. Let's try another. This one, again, if we look at the final answer, we can see it's a 1,4 addition, 1, 2, 3, 4, across the molecule. The two original pi bonds have disappeared, and we finish with a pi bond in between the two original pi bonds. So let's look at the mechanism again. So the pi bond on the conjugated diene reaches out for the hydrogen, which causes the hydrogen to bromine bond to break, and we produce that carbocation intermediate. And that carbocation, of course, is sp2 hybridized again, just like its two carbon neighbors to the left. So we have an ability for those electrons to become delocalized and move across the gap, and that gives us our second resonance structure, as we see down here, with the positive charge now moved down to the apex carbon there. It's electrophilic. The bromine is nucleophilic with that lone pair of electrons when the bond breaks. So we form a new bromine to carbon bond, and we get our final product again. A 1,4 addition, and the double bond is now right between the two original double bond positions. Let's try one more. So again, the hydrogen bromide is going to be the electrophilic part of the reaction, as the conjugated diene reaches out with electrons to grab the hydrogen, which is having electrons pulled away from it by the bromine because of the polarity of the bond. That's going to pop the bond to the hydrogen as it maintains its duet, and will produce a carbocation intermediate, which is sp2 hybridized at that carbon, just like the carbon next to it in the double bond. So those electrons can swing across, delocalize, to produce their second resonance structure. Now that positive charge has moved over to the fourth carbon in the chain, 1, 2, 3, 4. It's electrophilic, and so the bromide reaches out as a nucleophile, and we form that new bromine to carbon bond and form our final product.